Beautiful people, I hope you are doing great today. So, in today's video, we are going to start a new series of lessons related to advanced syntax. We are going to see syntax from a mathematical property related to phrase structure trees. Most of the information that you will find in this video is taken or are by the famous scholar Andrew Carney, and he's a professor in Arizona, specifically in Texas. So the book is called An Introduction to Syntax by Andrew Carney. One important thing that you should bear in mind is that even if you have trouble with the formal definitions, try to understand the initiative idea behind them. So even if they are scary, don't be scared about them. Just understand the initiative idea about them. So don't get lost in the details of the formalism in syntax and so on and so forth. The first question that you are going to ask yourself, or may you ask yourself, is what is structural relations? Or what are the structural relations? They are the formal relationships between items of a tree. When you draw a tree, for example, you are going to find there are some constituents in the tree. These constituents, they are combined or connected with something called relations. These relations, we call them structural relations. The question is why we should care about them, or why should we care about them? We want to be able to talk about specific relationships in term structures. So if the professor or one of the scholars asks you what is the relationship between an NP and VP, you will be have or you can say you'll be able to answer him related to the structural relations rules that we are going to discover and delve into in this video. So bear in mind that structural relations are actually very simple. Don't let the formalism scare you. So basic terms, when we talk about a tree, we are talking about some specific elements of the tree. So as you can see in this video, we have letters and we have lines. The letters like M, N, O, D, E, F, G, H, G. So please bear in mind that we can replace them with A, B, C, D, E, F, G, H, G, which means we can replace this M with A, B, C, D, E, F, G, H, G. So these letters and these lines, they are the component of a tree in syntax. So when we talk about these lines that are connecting these letters like A, N, B, or M, N, O, D, and so on and so forth, we call them branches. Those lines are called in the structural relations branches. So labels like M, N, O, D, E, F, G, H, G are called labels. And sometimes we call them nodes. So M and O and so on and so forth are called nodes. So M is a node, N is a node, E is a node, H is a node. And these nodes are combined with branches, which are the lines that are connecting these nodes with each other. The hierarchy, or I can say the higher hierarchy level of this tree is called M. So this is the higher property in the tree. And we call it root node. It is the first one. There is nothing above it. So we call it root node. Whereas these, we can say sisters, or we can say these daughters, because this is a daughter of M and this O is a daughter of M. So both of them are sisters, and the mother of this N and O is the M. We call them non-terminal nodes. Non-terminal nodes. And we have another term which is called terminal nodes. What is the difference between non-terminal nodes and terminal nodes? It's easy. When we are talking about non-terminal nodes, we are talking about a node or nodes that they have a mother, that they have something that is related to them. Like here, N and O are non-terminal nodes of the root node of M. Whereas terminal nodes, they don't have any branches. They are just like this. G, H, G, F, A, D are all of them called terminal nodes because they don't have a specific branches that will, for example, down towards these aspects and so on and so forth. So we call it terminal nodes. So if the nodes they have a mother, we call them non-terminal nodes. But if they don't have, for example, branches like G doesn't have any branch or H doesn't have any branch, we call them terminal nodes. They are alone. Whereas M, N, and O they are They are the daughters of M. That's why we call them non-terminal nodes. Domination.